I don't know. I felt I was unfairly picked on. So let's solve this one. What do we have to do with 30 horsepower? Find out the watts. Yeah. At least that's what we're going to do, right? So 30 horsepower times 745.7, and that's watts per horsepower, right? That's going to be our power. And then I'm just going to say that that's force times 25. Yeah? So I'm using this formula that power is force times velocity. I need to separate my... there. Does that help? That helps. Examples, cheat sheet. Yeah? And now we can just multiply and divide and stuff, right? So 30 times... Can we stop the private conversation? I would appreciate that. I'm getting that F is 894. Yeah?
We're looking for the force?
Yeah, we're trying to find the force resisting the motion. Yeah? This ends up being, if you divide by, if you want to figure out the newtons or the pounds, if you divide this by 4.45, that's how many newtons there are for a pound. You get 201 pounds. That's a lot of force. A big, strong... What is going on in the hall? That is a big, strong person, like a enormous... An enormous football player can exert about 50 pounds of force. Big, strong person can exert 50 pounds of force. This is like 4 very large people running at like 60 miles per hour. I guess it doesn't really work, does it? Yeah, I don't know. But anyway. Well, it's 30 horses, right? Yeah? Yeah? Yeah, there we have it. All right. Let's try it. Get out the whiteboards. Go mama. It's all up here. So these are going to be, you can just, we don't need to use the full-fledged thing just yet. Okay? So these things are just going to be power is work over time, right? Or power is force times velocity, right? So that's what we're practicing right now. And then we're going to mix it up here. So use these guys and these guys for these first whiteboard problems. Yeah, that's right. Yeah. You're off by like a power of 100 or something like that. That's right.
Oh, I just typed in the wrong number.
Watt is the unit.
Are the numbers right?
Yeah, that's right. Yep. Hey. Orbit Lab, all right. That's right, that's right. There you go. Hey, we're just learning about watts. That's right. Yeah? Yep. What's up, Brady? Geez, nobody's made that joke before. Woo! That's right. Orbit Lab. Are you guys looking for Orbit Lab? It's over by the computers. Just find a computer that has... There you go. That dog will hunt. It's posted like on a piece of paper next to it.
Go to the next one.
You're like so antsy. Enough caffeinated beverages for you. Has everybody got it? It's just work divided by time. Are we good? Are we ready for the next one? I'm a wonder, yep. Brody Richter. So now we're just looking for time. I think you're going to do this, right? Aren't you? It's like, yeah, you got it. Yeah. Who is it?
Can I turn in these?
Oh yeah, turn them in.
All right, thanks.
We got like
Oh, no.
189. I don't get that number.
No point 189.
I don't. Oh, you got one over the right answer. You want to go work divided by time, so it's 127. No, wait, well, 671 divided by 127. You love me? I love you too. That's right. He loves me. Did you say? Or did he love you? He probably loved you. That's right. He's blushing. Huh? That's right. Yes. The watts is the power, right? Yeah. And the joules is the work. So you want to do joules divided by watts, right? Yes, yes, yes. Did that answer your question? So it's 671 divided by the 127.
So is it set up with randomly equals 127?
It is 127 is 671 over t, yeah. But then when you clear that, it becomes t is 671 over 127. That's right. Yes. Yeah, only it's s for seconds. Yes. Never mind what? That's right. So you're doing time, right? Time is work divided by power. Yeah?
Seconds, maybe?
I already, I have that one worked out. Yeah.
That's right. Homework for today.
Yeah.
Did you do it last night?
Yeah, I left.
I've got a stamp here. No, you're doing the wrong thing by the wrong thing. Yeah. No. This is higher math. Okay, so you're going to say 127 is 671 over t, right? Danny? Don't. That's mean. Danny, this is what you have, right? So what you do is you just switch the t and the 127. T is, yeah. Because remember the 127's in the numerator, and so you can. We ready for the next one? What work does a 1.5 horsepower motor do in 1 minute? 2 things that we must do before we can solve. What's the first thing? Turn minutes to seconds. 1 minute is how many seconds? 60. 1.5 horsepower. What do we do with that? Can we use that? Turn it into what? That's what I'm trying to.
Just divide it.
Multiply it. Yeah. Come on, some of these will work. Just I don't want to throw them because it's like against my. We're trying to find how much work. And it's a lot of work. It's going to be, a lot of joules per second times a lot of seconds, right? That's right. Yeah, you're trying to solve for work, right? So work is going to be power times time, right? Rate times time. A square magnet.
Well, like one of those straight magnets.
There you go. Yep. Yeah, I do. One of these guys. I think that's the one you were using. It's joules. It's actually joules. It'll be watts, seconds, or joules. Yes. I don't get that number. I do get the bottom number that you've got. Yeah. Ladies and gentlemen, over here we got Jacob King, and he just turned how old?
Monday.
What?
Monday.
I know, but I won't have you Monday. 17 years old. Big round of applause. Stand up for us. Not to make his birthday something extra special, and when he's not likely to forget. Even after years of therapy.